or the, I'm not sure first if everybody is here because most of the people stayed connected during the break, but it's not clear if they came back. I don't see any activity even in the chat. Ah, okay. 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 Maybe we have to wait. I have only 8 people connected. Yeah, 8. Maybe you can wait a couple of minutes. And we're going to move to the next. If for people that are already connected, if you have any question, do not hesitate. You can also unmute your mic. We are not on, I mean, we're only 9 or 10 participants right now. So there is the possibility to speak. So we wait a couple of minutes maybe, and then we move to the next exercise. Okay, so we can start the new exercise. That one is related to, as you see, it's as you can see, it's number 4, and it will be on the fires, on the product of fires and the relation with the precipitation anomalies to better understand. So basically, it's technical but also scientific question about fires and precipitation anomaly in the region, in a specific region of the RDC. And so basically, here the exercise is to go to the region of Bandundu in RDC, and we can analyze the evolution and of the fire detection over this region in average. In average, it's sometimes more accurate because of the very noisy signal of the modifier. This kind of average value over a region is most of the time more stable and more relevant. So it's so this is the I let the chat open. So this is the exercise. It's about the severity of the fire conditions with respect to the climatology. So still the connection between what we detect for a specific case compared to the climatology. That would be the reference. And could you explain this by the evolution of the rainfall? So basically, you have to try to find a way to plot both the fires and the precipitation during the same period. So this is I think because there are many different methods to plot that. So basically, what we're going to do is first, if you can plot the maps of the 10-day fire at 10 kilometers resolution. So this is the number of fires with this resolution. And this is the region of Bandundu, by the way, of RDC. So first you have to open the map and you can select the product of fire, and you have to detect, you have to select by the 10 days, the 10-day product. So when you are on the map product, you will see there is only one product called fire, but take the 10 kilometers. It's a bit, if it's a plot of, if it's an average of a region, it doesn't, we should get the same product, but the same results, but it's easier to compute with a coarser resolution. So select the 10 kilometers, and then this is typically the 10 days fire at 10 kilometers. So it's normally the first product you can have in your detection. And you can zoom in into the region of interest, and you have to select the condition in the 1st of August 2020. So basically, you look at this date indicated here is the beginning of the period. So basically, if it's 10-day period, it means it's the computation of modifier from the 1st to the 10th of August. So then you can you should get this kind of graphic if you use the same color bar. So again, if you want to add the layers, and don't forget it's this button, it's the border layer, it's the vector layer. And in that case, if you want the region, you have to select the level 1. Then you have to go to RDC, and it's this region here. It's this big region. It's one of the biggest in RDC. It's relatively easy to find. And it's in the southern Congo. It's a southern RDC. It's just north of Angola. So once you have done this, you can generate a second map of, you can generate the second map, which is that one. It's the same product, but it's the anomaly compared to the climatology. So you can create a new map And then in the product, you select the fire. Be careful to select the correct resolution, and you select the fire 10 kilometers long-term average. Sorry, the difference to LTA. Difference to LTA, and then because the two products are linked, it should be exactly on the same place. Normally, by default, the two maps are they are linked. But select again. Be careful with the time. If it's not the good period of the good period, use the bar down of the So there are different type of differences. This is the relative difference to LTA. So it's a different way to compute the. I think it's divided by the relative is maybe VJ, or I think in the procedure chain the relative difference is divided by the. It's a percentage, right? Maybe compared to the climatological value. It's the difference compared to the climatology for each pixel. It's a relative difference. So it's in percent. It's not in terms of fire here. But be careful. But you can plot. I mean, there is no specific interest of using that one instead of the relative difference. Of the difference. You can use both of them. But you will see the different. If you use the 10 kilometers difference to LTA, it's a bit different. You will see it's a bit different. You can expect maybe less variation over there.
Yeah, Chris, so it is actually described also in the description of the product, relative difference to the long-term average.
Yeah, the procedure chain.
It is 100 times, sorry, yeah.
It's different. I think it's divided by the climatological value. So basically, it's a percentage of difference. I think so. But you can use both. It's not a big deal. You can use both the difference or the relative difference. It's not really important. Okay, then if you did it, you can create some profiles. So I ask you to generate two types of profile. The first one is the kind of climatology for 2020, climatology and the values, the 10 days values per in average over the region. So basically it's that image, it's that's plot. In that case, you have to use the new graph. In the new graph, you will select the profile. So once you have identified the region, that should be when you select the region, it should be the RDC Bandandu on the top, the selected region. Then you select the product you want to use. So basically, it's this kind of product. So it's the modifier. So it's 10 days fire and 10 days LTA. You could also add the mean and max if you want to have a better, a nicer view of the spread of the variability in between the years. It's also a possibility. So I can do with you now. I can redo that if I want to integrate the min and max. So I have already, oh, sorry. There it is. So this has been done. Okay. So basically, I have already generated this graph. I don't know if you did already, but what I can do is I can add the min and max to see what is the variability. So in that case, I go to product, fire, modifier. I will select the LT min and the LT max. When I selected, I added in the list here. I can directly modify it. So I don't want column, I want a line with 2 of a thickness, and then I will plot in gray both of them. Here is the max. I can go in gray, and I update. I update the graph. Somebody speaking?
No. Anybody speaking? Me speaking.
Okay, so this is the typical graphic. It's a bit strange. I have a small problem of interpretation of that. Because maybe the long term, I didn't check before, but because there is a conflict in between the two graphs, because according to that graph, the LT max, maybe the LT max is should be checked, because okay, you can see that if I remove the graph of min and max, maybe I didn't check before, so I'm not 100% sure about the quality of this graph. You can see that this event in 1st of August to the 10th of August it's far above the climatology. And this is relevant when you make, so basically it's a very abnormal situation. So basically when you have this anomaly of fires, and it's also seen in the climatology. Here it's a bit less active, but as you can see here, but in the center part of the region, you have a big increase of the fire detection. And this is also observed, I mean, in average over the region, you have this kind of peak. And if you make we can add the ranking. So basically, you know how it works. You have to make a new graph. That time you have to create a ranking with the fire datasets. This is the 10 days fire, and you can add it. You can generate it, and what you can see is that it's this anomaly, this strong anomaly, is confirmed by the ranking. Sorry, because we are focusing on a specific period of time. You see, the big anomaly is only on a specific time. We can select a specific period also for the ranking. This is done by this box. I show you previously for one another exercise, it was the same. So here you can enter the period of interest where you want to focus on your analysis. So basically here it's from the 1st of August to the 10th of August. And then you create the time series. Oops, sorry, of course you select all the years. For those who just joined, Youssef, maybe you just joined. I just quickly show you I will show you the exercise. So basically it's an exercise about fires and the link with precipitation. So the exercise is for the region of Bandundu with the fire detection and anomaly in August 2020. Question about the severity of the fire conditions with respect to the climatology, and is it possible to explain this by the evolution of precipitation? So I asked to plot the two maps for the moment of Modi's fire at 10 days resolution, 10 kilometers resolution, 10 kilometers resolution and 10 days period. So this is the anomaly. No, this is the normal values for the 1st of August. So as explained previously, it's the first day of the period. So we are looking at the rainfall for the period from the 1st to the 10th of August. This is a detection of fire, number of it's the fire counts in the 10 days and 10 kilometers resolution here in color. And I asked also to plot the whatever you want, the relative difference to long-term average, or the difference to long-term average that provide a relative similar product, but maybe the relative one it's a bit stronger in intensity. So maybe that one is relatively interesting. And once once this is done, and it's what we are doing now. It's the two graphs. One is the profile. It's the profile of the region. I mean, it's the profile, the temporal evolution of the fire detection over Bandundu in RDC compared to the climatology. So basically, you can see here you can clearly see the evolution with a peak of fire in summertime, with two peaks in June and in August. And what we observed here with the peak of fire detection, it's related to the climatology. I mean, it's the season where we have a maximum number of fire, but it's also this specific year in 2020. You can see we have almost 2 times more active fires detected in the region compared to the climatology. So what we can do now is the ranking of this specific period compared to the climatology. It's what is done here. So in that case, you have to create. So you have to create a new graph. You have to create a ranking ranking graph with the monthly, with the 10 days fire product, 10 days fire product. Yeah. And because we are focusing on a specific period during the year, we are not, if you don't enter any kind of information and you just plot the years available, you will have the ranking of all the detection compared to the distribution of the year. But in our case, we want to focus only on this decade, which looks very abnormal compared to the climatology. So you have to enter in the box, in the bottom of the time series graph. In the bottom on the right, you have a box with the season. And in this box, in that box, you have to enter the dates of interest. So basically, it's 1st of August to 10th of August to have the period of the year.
That you are working on online version of this.
Sorry?
I cannot see that you are showing it on the online version. Are you showing it on the online version?
No, I'm in my presentation.
Okay.
I can also work with the.
Yeah, I thought you were clicking and show.
No, it's where is, okay, it's my presentation here. This is the, what is that? So basically, I can redo so if you prefer, I can show you so basically it's ranking, 10 days forecast. You select all the year, and I started to work on that previously, and I made a mistake. So this is the, okay. So if you, yeah, it's maybe easier if I show you. So I selected the good region, okay. I select the good variable, which is a 10 days fires forecast, okay, all the years, and the specific period of the time, which is the first decade of August, to analyze this anomaly. What we can do now, to change a bit, because we have already done that, because we're gonna retrieve this kind of thing. Again, what we can do is the Z-score, because I mentioned previously, you cannot see really the climatological trends of the fires in the region from the beginning to the end of the period. The Z-score, this kind of, if you check this box, you will have another information. So it's not a ranking, it's a ranking, but with the chronological values of the years. So if I create that, you will see that it's exactly the same information that that one, but presented different with a different manner. And what is very interesting to see is that, okay, the first information with the ranking that I already done previously is that our this specific year is the worst on record. We are about 2 times above the climatology, okay? In average, we had in general 7,185. So it's the number, yeah. And now we have 14,000, so it's exactly the double. So it's a very nice information showing that we are, this is 2020 is the worst year on record about the number of fires detected. But what about the climatological trends? And this is it's exactly the same product. Huh? I don't create any other product, but it's just anomaly compared to the LTA, and with, you see the chronological order is respected for the years from 2002 to 2020. And clearly, what we can show is we find the same results, showing that 2020 is the worst on record. But I could see a clear trend toward an increase of fires in that region. So obviously there are some noise. I mean, for example, this year 2004 is really there is also a strong signal in 2004. But as you can see, we have only few days, 2 years basically with negative anomaly since the last 10 years almost. So clearly there is a trend. It's also interesting, maybe I didn't notify that, but maybe you can also look at that. For example, we were looking at the value for 2014. I didn't check. I can try on the, but for example, you can, or maybe 2009. What we can do, you can also remote the time to see maybe. You see the timeline here. You have the full timeline, and you zoom into a specific period. But what we can do, we can extend. So basically, we are looking. We can start to look at the 2004. The case in 2004 to see what is the pattern if there is a specific anomaly in 2004 compared to that anomaly. So basically I move back. So you see I moved the zoom to have all the access of the data sets. I didn't check before, so I don't know if it's gonna work, but if I click on the 1st of August 2004, it's the same data sets for another period. and it can be analyzed in relation to I mean, that can be also observed. I mean, we find the same patterns. It's a similar pattern. We have a different shape of anomaly. And you see that even this map has been updated. So basically, we can really easily compare 2 years. We can move from 1 year to another. So for this specific question about the origin of 2004 versus 2020 anomaly of the fires, it's not obvious. We have to investigate a bit more. But the thing I would like to show you is the easy of use. I mean, when we show, we try to reduce the size of the data burden, the Earth observation burden, to increase the time of analysis. You see how it's easy to move from one period to another, from one region to another. And this helps normally the beneficiaries. So basically, you have this kind of for the moment we have generated these 4 maps. I hope you're still following the thing. I have an extra map showing this kind of evolution with the climatological trend toward an increase of fires detection in that region. And then the additional question of the exercise was about the link with the evolution of rainfall. If that trend can be related to the rainfall. So okay, so what I plot here, and what you can add, is a time evolution of SPI and rainfall precipitation over the year and over the months, sorry. So basically here I'm using the monthly rainfall difference to long-term average. We have the SHIPS 1 month rainfall long-term average. So basically it's maybe, I can remove one, at least one. And if we focus just on the easiest one, so basically we have here, it's easy to manipulate. You see, I can remove or add some data sets that have been already created. So you can create a profile with the precipitation, the monthly precipitation compared to the climatology. And you can also add the SPI, because I mentioned to you that the SPI is also, it's a very powerful instrument, even if over a region, sometimes we may have some difficulties, but maybe I can show you and I can explain a bit the differences you can find by using the SPI versus precipitation and precipitation anomaly. So basically what you have to do first is this kind of graphic with only the 3 variables I mentioned. So the SHIPS monthly rainfall, the rainfall of SHIPS, monthly rainfall, the climatology, and the rain SPI 1. So basically the monthly SPI. So you have to create a new graph. You have to select the region. You have to go to rainfall. You select in the rainfall, you select the rainfall you want, the data set you want. So in that case, I use the SHIPS. And then you select the monthly product and the monthly long-term average. Then either you plot like that, or you add now the SPI, or you can add later on. It's up to you. So now I'm looking at the GRC SPI. This is so the 1 month cumulated rainfall. And because we are focusing on 2020, I select only that year and I can generate the map. So you will get this something like There it is. So basically it's the same. So I can remove that one. And then you can add other product, etc. So just so basically what we have. So we have the climatology available all the year because it's a climatology. So we have also data set from November and December, whereas the data set of the monthly rainfall indicated in dark blue here is available until October because we're currently in November, so it's ongoing. Then what you can see is the SPI behind the black line. It's the SPI. Be careful, it's a different scale. As I mentioned, SPI is a standardized value, and I know that SPI under -1 is a drought condition. So basically here we are in a drought condition, -1.4, 1.5. It starts to be relatively severe. And above 1, so for example here, it's a flood. Or wet condition, not flood, sorry. Wet conditions, floods, it's different. When you look at that versus the precipitation anomaly, sometimes it looks weird. For example, if you look at here, 1st September, it appears that the precipitation of the monthly precipitation of Sherps is lower than the climatology, whereas the SPI is positive. So even if the standardization can generate some differences, it's a bit weird to have this kind of conflict. In fact, it's because the SPI there are two differences. The first one is the problem related to the average of the SPI over a region, as I mentioned previously. A difference in the average of SPI, because it's standardized, you're completely disconnected to the raw values. So if you have just 5 millimeters of rainfall in the driest region of the world, you will have almost infinite value of the SPI. So when you make the average, then that will create a mess. This is the problem of the SPI. But you have also another point, which is the SPI is calculated more frequently. It's calculated with a moving window every decade. So basically here, you see we have a data for the 11th of September, we have a value. In fact, it's the value for the two last decades of June and the first decade of July. The two last of August and the first one of September, etc., etc. So basically, if you want to compare the value of one data to another, you should compare the last of the decade. So for example, the 21st May should be compared to the value of May. The 21st June should be compared to the other. It's still possible to see some conflict, but this should be related to the problem related to the average, the space average. But in any case, for example, here, I'm sure it's not related to that. It's certainly because you see in August, we had a very positive anomaly, and the moving window of SPI didn't see anything until the second half of August. So you have a good chance that this big anomaly of precipitation recorded in the Sherps is mainly occurred at the end of the month. So when you calculate the moving window of the SPI, you get all the data, the extreme values at the end of the month, and that's why you have this high value of SPI, whereas the anomaly is still under the climatology. And then the second half of September is really dry, as seen by the SPI, and also as seen by the accumulated rainfall. So it's just to show you a bit, not the complexity, but it's still very important to know what you analyze, and it's always better to not to keep in mind the positive and the uncertainties related to a specific variable. So if we want to explain this very important fire detection in that region during the 1st of August, close to the, around this region, it appears that there is absolutely no explanation. Okay, we have a small value under 0 of SPI, standardized, but it's even bigger than -1. So we are not in a drought condition in any case, compared to the climatology of rainfall. So if you go back to my presentation, if you follow this morning the SPI calculation, because it's standardized, in between -1 to +1 value, we have about 68% of the cases of the climatological cases that are in that conditions. So basically, when we have this kind of rainfall event, which is in between -1 and 1, that means we are in about in the 2/3. We are close to the normal conditions. So we cannot explain the peak of fires related to that. It's also visible if we plot the SPI, the monthly SPI over the region during that month. What you can see, we have mostly blue values, meaning a bit above the precipitation. This is the months before, because of course, when you have a drought condition, that occurred usually 1 month before. So if you want to plot this, first you have, if we go back, sorry for the exercise, you have to analyze the SPI conditions. And we have to be careful, because in that case, we have to remove the link in between all the graphic. So basically now you can, if we finish the analysis, you can create a new map with the GRC Mars SPI. So you have to create a new map. You select the GRC SPI. And when you open it, you have immediately to remove the links for the time series, because we want to see the conditions previous the event, not during the event. Because if we look at the SPI in August, like we did here, or for the fire, it's August from the 1st to the 10th. If we look at for August, the SPI, it's the precipitation from the 1st of August to the end of August. So there is no sense. I mean, we have to look at 1 month before. So that's why we have to disconnect the 2 time series of the graph. So when you have opened the GRC SPI, you can see the time series here. You unlink the time series, so it should be in red now. And then you can move from 1 month to another. You can play with it. You will see that for the moment, if you change this map, that doesn't change the others. If I'm going to that time series, I know that this time series is related to that one, at least. So if I change to another date, I will have an update of both situations without moving that one. So what we can say with this exercise is for the scientific question is that we have, it's quite obvious that this is certainly related to the human activity. Basically, it's a human that create this kind of fires. And in any case, it's not related to the precipitation. And you have different functions to do that. So you have you plot the profile, the ranking, and you have also to disconnect if you want to see the conditions prior the event. You have to disconnect, unlinked the time series. Is it okay for you?
Okay for me.
It seems we lost some users. Okay. Okay, so now we're gonna move to the next exercise. We're gonna move to the agricultural aspects. So now the exercise is to analyze to monitor the drought condition in Mozambique in May 2020. And the question are, what is the drought situation in Mozambique in April, May 2020? Do you see the impact in terms of soil moisture and vegetation? When occurred this event within the rainy season? And do you see the persistency of the anomaly of rainfall, and how do you explain it? So now we're going to move to Mozambique. So this is what I'm proposing. So you have to plot again 5 maps. The first one, I mean, so you have different way to show the monitoring, to monitor the rain and the agricultural situation. So first, you can directly plot the monthly rainfall for a specific date, so in April or in May. You can analyze the anomaly of rainfall compared to the long-term average. So basically, you have the first map, which is the rainfall. So it's a basics map we saw already several times. Then you have the anomaly with respect to the climatology. So this is also something we already shown in the past. So I let you time to practice. What you can do as well is here you can see it's another plot. It's the SPI, but for 3 months. So basically, it's February, March, April anomaly, which is not this very long-term anomaly is not available for the anomaly, for the rainfall anomaly, which is basically monthly anomalies. But for SPI, we go up to 3 months. SPI 3 months. So it's for each grid cell, the cumulative period is from February for 3 months, and then we feed the gamma distribution that has been transformed into the normal distribution, and then you have this situation. So why it's complementary? This is the very short-term conditions. So basically, the last couple of the last month. So it's really recent. Here, it helps to detect more persistent droughts. And in general, SPI is really robust as soon as you go for a longer time series because it's a technical issue, but the problem of SPI is when you have 0 values, so no precipitation at all during the period, because you have to fit the gamma distribution, which is not defined in 0. So you have to find a way to solve this problem. So when you work with 10 days, 10 days data set, for example, you have a lot of grid cells that record no precipitation during those 10 days. And in that case, you're a bit in trouble for fitting a correct gamma distribution. In opposite, when you work with 3 months cumulative rainfall, you have less chance to have that, to record that. So it's much easier, and your fitting is much more robust. So in that case, if you plot, if you're doing the exercise, you can plot the rainfall, the difference of rainfall compared to the climatology, and the SPI. Then what you can do is You can plot as well to complement the anomaly of rainfall during this region. So you have to select Mozambique. So again, for adding a map, adding the borders, you have to click on that bottom here, and you add the level 0, so the countries. And then you plot the maps, the countries, and once you have the countries, you can select Mozambique. It will appear in red. And once it's selected, you can select a new graph here. So you select a new graph, and then the products. So basically, it's you have to select cumulative. So it's not profile; it's cumulative. That you select the rainfall. So basically, we are using the monthly rainfall, and we use the rainfall from ships, but you can use other. So basically, I'm going to use the monthly one, the monthly rainfall datasets, and the reference, because I need a reference for the cumulative, so I will use the long-term reference. You have to select, so basically, this is the current, and this is the reference. It's indicated in the graph. The current means the one you want to analyze. The reference is the climatology. And then the box propose you some period, or so you can, it's easy to show you the 2020, so you can select the year of 2020, and you can plot the map, you can plot the graphic, and you will see this, you should get this kind of graphic. So basically, it's what we can see. It's at the beginning of the season for January, we're very close to the climatology. Then in February, we are under the reference period. And then we are completely red until the end of October. So clearly we are in the dry conditions here. But we're gonna analyze a bit in more details this kind of situation. I don't know, I don't see any questions, or okay. So basically you can add other information like the ASCAT METOP soil moisture index and the spot, the FAPAR, so the anomaly of vegetation, the Z-score of FAPAR, and the soil moisture. So what I mentioned previously for the dataset, for ASCAT METOP, we don't have the anomaly, so we have to provide only the soil water index. So if you plot this map and you want to compare with the others, it looks like the soil moisture is maybe, or especially over Madagascar, it can be connected to the SPI3, showing a dry condition in the south and normal or wet condition in the north. But because we don't have the climatology, we don't know if that region is associated with an anomaly, or is because the soil or the climate is a bit different, and the soil is naturally a bit drier than in the north. So we cannot conclude anything about that because it's a raw data set, and it's a bit complicated to interpret like that. But for the FAPAR, it's a bit different, since the FAPAR is an anomaly, so it's respected to the climatology. And what you can see here, it's there are some sign of negative anomaly over there, and a bit over there, and also in south. And you can see that it's not straightforward. I mean, the relationship in between these maps are not completely straight. And it's maybe because of when we had this anomaly, when the anomaly occurred. And to analyze, it was the question previous. When occurred this event within the rainy season? So to better understand what happens in that specific condition, I think it's important to plot the matrix to see when we have an anomaly and what happened, where is this anomaly. So basically what you have to do is to create a new map. So you can generate a map of, I can go to my, so I can create here, it's what I did, I create a matrix, but so basically you know already how to generate this. It's the monthly rainfall. So basically you use the entire period, so the 10 years period, I mean, not the entire 10 years period here, for example, and you see the precipitation amount for every month and every year, and you see the seasonal cycle of the precipitation, basically with a strong precipitation at the beginning and the end of the year. And you can easily see the anomalies, a strong anomaly of rainfall that generated the big signal in the SPI, and also observed in the cumulative period. It's this anomaly here that is really lower than the other months. I mean, March was really, really abnormal. February, relatively normal, but March and a bit of April was really abnormal with very strong and dry conditions. You can also plot, instead of plotting the monthly precipitation, you can also analyze the box of the anomaly of precipitation. So it's a bit more noisy because we are working with a relatively coarse resolution. And if you add a matrix of that, you can see the strong anomaly of rainfall at the end of the season. And so there are two consequences. That's why I really like matrix because it provides a lot of information, because you have the information of the anomaly, you have the information of when it occurred, and you have also the anomaly of and you're really well known, you're really well aware of the period of the year when you have this kind of extreme case. Because it's at the end of the month, maybe the impact on the FAPA is a bit lower than what we can have in the middle of the season. It's the first consequence. And it's also worth to note that if you have a very strong anomaly, then if you look at the anomaly for the rest of the season, if you look at the raw anomaly of 2020, what you see? You have a very light increase above normal situation, then a period with negative values, but 3 months, namely February, April, May, with not very significant negative anomalies, and a huge one in March. And when you have this kind of events, and then the rest of the year, it's really, really low, the anomaly. Why? Because you have out of the rainy season. So the cumulated rainfall is never strong. So when you look at the profile, you can better understand this shape. And be careful with that, because when it's cumulative, especially for rainfall, one single event, like for example, imagine you have a normal situation everywhere except that month. What are you going to get? It's a normal situation until that month, when you have an increase and a big reddish zone starting. And this reddish zone will be persistent until the end of the year, even if the rest of the year is normal in terms of precipitation. You go back to the normal situation. So you, at the end, it's true that you have a deficit at the end of the year of the precipitation. But this graphic, I'm not sure if you look at 12 months of cumulative precipitation and you look only the last values here, I'm not sure it's relevant to compare with, for example, indicators related to vegetation or fires or even water body or these kind of things. So yeah, we have to be aware that the cumulative profiles can generate some, I mean, you have to correctly interpret the cumulative profile. It's maybe more adapted for vegetation, for example, because you have better information about the cumulative, because the vegetation, if the vegetation restart if the vegetation becomes close to the normal, finally you will reduce the cumulative graphic. In fact, to get a normal condition at the end of the year, if you have a dry condition at the beginning of the year, you expect a strong wet event to compensate it at the end of the year. So basically, you expect a flood to compensate and to get a normal conditions. It's true. It's wrong. Sorry, it's not something you can. So yeah, okay. I stopped. We could discuss a lot of time on that, but. You can also, something I didn't do for this graphic is also we can add all together. I mean, if you're interested, is to plot this kind of matrix also for other variables like vegetation. I mean, FAPAR is also available for you can make a matrix, of course, of the vegetation. So for example, if you want the same products, so we go to the monthly value maybe to reduce a bit the, okay, we're going to take the monthly standardized FAPAR for the matrix. Sorry. So I select the region, so it's Mozambique. I want the monthly standardized FAPAR, okay? So I will get information about, and I can select, it's a bit dangerous because it's a high resolution product. I shouldn't go select too many years, otherwise it's going to be a nightmare for, that's the problem of the high resolution datasets. So I didn't select so many years. I select only 4 years. And because at country level, maybe it's too big, it's too large. I should reduce maybe my region. No, it's okay. So here it is. You can see that it's completely different when you look at the standardized values. It doesn't look so bad in 2020, even during the very dry condition in Mozambique in average. It's mainly because the strong precipitation event occurred in March. So we go back to close to the normal situation. But yeah, there is no necessarily linked to the negative impact. So maybe it's the reason. So that's why the connection sometimes in between the rainfall and the FAPAR or the vegetation is different. It's because we have to take into account of course the seasonal cycle. Is there a question for that exercise? Okay. Okay. Okay, so we can move to the next exercise. So it's really similar. So maybe I can go quickly to that one to have a bit. Sorry, do you want more, Kenneth? Do you want more information of the cumulative graph, or?
Now it's clear. Previously, I was having issues with understanding when you have at the beginning of the season is where you get trouble. Then the season recovers, but it still shows the red part. How to translate that information?
Yeah, it's maybe using that graph for rainfall. It doesn't mean is not necessarily relevant. I would prefer to use the kind of matrix. To me, it's much more interesting because the matrix is really you identify better the period of the time where you have an event, and if you have only 1 month with a deficit of rainfall and then you recover by having the climatology, I would say, after a few months, the vegetation and everything is the vegetation recovered most of the time. It depends, but most of the time it recovered.
Exactly. Because in agriculture, that has a big impact because it means like a crop. There's a certain stage where the crop probably there was a problem, and then after that there was recovery. So it's better to explain. With the matrix, is very clear if it's only 1 month or 1 decade that the problem was, and then in terms of agriculture, it's better to explain it that way.
Yeah, the thing is, the way to interpret, you may find that the explanation when you look at the profile. I mean, you just have to analyze the space in between the deficits. If it's constant, it means you don't have additional anomalies, either positive or. When you have an increase of the deficit, it means you start to have a negative value here.
Okay.
So when it's constant, it means there is no, it's stable. When it's stable, so it's the only way to find the monthly data from the cumulative. But yeah, I would say cumulative is really powerful for vegetation, for example, because you can see the increase of deficit or the decrease. I mean the good situation or the bad situation, and what is the trend. Because the vegetation, the status of the vegetation is the real status. So if it's under the climatology, it means it's really under the climatology. For precipitation, when you look at the cumulative, it's a bit different. So yeah. Okay, so I think it's
it's clear now. Thank you.
Okay, so just so now, I mean, it's a very similar exercise for agricultural purpose. It's for the crop monitoring in Cape Town in January 2020. Maybe here it's also to have to show you some specific conditions because you know that in that region, it's another region where we record an impact of the climate change. And we have also some very dry conditions. Recently, Cape Town was really had a lot of issues with water resources, for example. And the idea is also to see the impact of the vegetation. So basically, here this is what I propose. Maybe because we have only half an hour, and there is another exercise for sonography. So basically, I will maybe just present you. If you have any questions or if you have questions or if you, but I think it's a bit redundant to the previous exercises. So let me know if you in the chat if you really want to do it, or if I can explain briefly how to do it or to interpret the results. So basically, I explain quickly. You can plot the maps. So basically, it's the NDVI, the anomaly of NDVI through the VCI, and the difference over the region. So basically, you create a map. So it's still the same methodology. You click on new map. You go to the region. You select the vector layer. So you select layer 1 to have the regions. And it's possible for you to see the Eastern Cape region, which is that big, that one, big one, north of Cape Town. And you can select products like NDVI or other. Also, you can also plot FAPAR. In that case, I created maps for 1st January 2020. Okay, so for and this is monthly standardized FAPAR. So it's the dataset from January, different maps of January. So basically, I plot here the NDVI and different anomaly, the VCI and the difference. And I plot also the FAPAR and the Z score. So basically, it's the anomaly again. And the same product, but with another platform. This is the FAPAR derived from Modis, and this is the platforms from Probabil. So in that case, you have the situation, so the current situation, but you have also the anomalies. So what we can see here is the strong negative impact visible in most of the anomalies. So here you have the NDVI, VCI, which is clearly associated with the negative anomalies over there. It's also visible in the differences. The intensity is also related to the absolute value of the NDVI. And in the Z score, you have also the detection of our negative region for both MODIS and SPOT with different intensities, especially along the coast. So you can have an access to the uncertainties of your estimation of the FAPAR. And you have the negative values. So basically, for the 5 maps now, I hope you understood how to generate this kind of map, or you can link them all together, or you can link also in the time series. Be careful when you you set up the specific date for maps, for example, there's 3, and you create a new one later on. That will be with the last date available, not necessarily the one you have selected for the others. So as soon as you create a map, check in the bottom, check with the time series if it's the correct period of time. So if I'm going to that, so basically what is relatively easy to do. So okay, not necessary. I have to reselect. So basically I linked all of them, tac, 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 tac. And when you create maps, you can you have just to select the 1st January 2020, and automatically all the maps will be updated. So you don't create you don't make a mistake by looking at because if you look at 2 different completely period, that can be a big major issue for your analysis. So watch out when you create or add maps. Watch out about this. So I criticize a lot the cumulative maps for the rainfall, but I use again this, I create again the map of cumulative for rainfall. But in that case, you can see that there is a constant increase of the cumulative deficit. So basically, the first conclusion is the uncertainty of the FAPAR anomalies, mostly in that region, in the coastline. Over there, we are a bit more in agreement between the 2 platforms, and we are in agreement also for the anomalies of NDVI. So there is a clear link in between the anomalies on NDVI and the anomalies of the FAPAR. Then what we can see is when we can analyze is the rainfall during the more recent years. the most recent months to see what is the origin of this deficit. And why it's important to provide also the references. I mean, when you look at so basically it's the cumulative rainfall for the period from July to January 2020. You see that we have an increase of deficits. That is also visible when if you create a profile. This is done here by this map. So you have still the 10 days rainfall period versus the 10 days precipitation versus the 10 days long-term average. And what you can see is that in January, you're just at the end of a long period with a precipitation deficit, which is visible here. So every decade, you increase the differences in between the climatology and the value. So in that case, you can see, okay, we have an increase of cumulative period. We have an increase of the dry conditions every decade. But there is another thing that is also very important because, okay, you can explain if you stop the analysis here by just plotting that. You can say, okay, it's because we had a few months of deficit of rainfall that created this kind of analysis. But let's look at the NDVI filtered and the long-term average. This is added here. And if you look at that and this temporal evolution, it's clear that there is a bias, a strong bias in between the two anomalies. So the bias could be explained by different reasons, a modification or an anomaly of the instrument. It can be related to a change of the platform. If you have a new satellite that replaces the previous one, you may have and that can be also an impact of the climate change. If you have a big and long-term change of the conditions, you may have this continuous anomaly in between the specific variable and the long-term average. But in any case, everything is explained by the deficit for the last months of 2019. So it's not because of the dry season of 2019 that you have this kind of anomaly. You have also a signal related to the climate change or an issue with the instrument. So that's why also most of the time it's important to have both the information, the temporal and spatial information, to see how your products are robust. I mean, if they are robust and if you can find an origin of that. So that's why I plotted this this exercise, is to show you that sometimes the answer of the relation is also related to the reference. So basically, potentially the climate change effect. So I think we won't spend too much time for that because it's redundant. We had already an exercise on for the agriculture just before. Maybe what we can do is to move on to the last exercise. Is there any question? No, no. Okay. Okay, so let's go back to the presentation. Okay, so now we move to fishery. And the exercise now is to analyze the fishery areas. And we're going to focus on the region of Mayotte in October 2020. So the exercise is to create a box around the island or somewhere in, of course, in the water. And the question is, what is the situation of the SST? Do you see the variability of the SST front in that specific box and chlorophyll? And based on that, do you detect some propice periods, some favorable periods in that specific region? So let's go for this last exercise. So basically, now we're going to move to the oceanography and to I close that one. So basically, now you have to create. So even if it's in oceanography, it's exactly the same type of graphic. So you have to create a new map. So basically, first we're going to plot in the products. Because most of the products are very sensitive to the cloud conditions, it's really recommended to use longer time series than the longer period than a daily product. Meaning it's better to use 3 or 7 or decades, or because the daily products are very, very, very noisy, and you have a lot of mask. For example, if you check the Sentinel product, which is very accurate, which is really good. But the thing is, well, as soon as you look at, for a specific region, you look at the data available, you will see that it's only, it's not very, so for example, if we go to that region, so it's a bit, it's a bit slow because we're working. Anyway, so Sentinel-3 is available on the platform, but trust me, it's really noisy because of the. So it's sometimes difficult to use it because of the cloud mask. It's also because it's not. Within a day, the satellite doesn't overpass over all the regions. So you have also some mask related to the overpass, the track of the satellite. And also for a scientific point of view, most of the products show that the fishery zone are mostly associated with stable situations, stable fronts of chlorophyll, stable front of SST, and stable. So basically, the OP fish is also associated with most of the time with something stable for up to 2 weeks. So it's nice to have an up-to-date product, but scientifically, maybe it's more robust to have a longer cumulative period. Anyway, so it's a bit slow with this. So basically, what you can plot is so you go to your oceanography and you select. So I'm using most of the time for this one. I'm using the PML product because it's a 3 days integrated value. So, and it's defined. So you see the 3-day chlorophyll, and if you want the 3-day SST is also available here, and the 3-day front. So basically, the 3 products I used to generate these maps. So basically, what I propose you is to plot the MODIS PML for the 3 products. I'm idiot. This is Sentinel-3. This is the Sentinel-3 for the same date, except that this is a 3 days. So this is the PML. Sorry, this is the PML SST. So basically, it's what I propose to plot now. So you go to MODIS SST. You have to select the region of Madagascar, of course, because if you select University of Ghana, you won't have that specific region. And then you select, for example, the 3-day SSD. So it's SSD compute within the 3 days. So if there is a mask only 1 day, you have the 2 others to generate your map. So basically, you have less, you have more data sets available. You can see compared to a daily product. So this is the daily the PML SST. I can add the African the border, the coastline. So you see the SST, and derived from that, you have the SST front. So you can now you have to create a new map. In the map, you have to Jurjen, I don't know if you are here, but it looks like I don't know why the borders of it's the first time every time I'm hoping
you see the button layers.
Okay, it's in my account.
No, yeah, well, you didn't refresh it because I changed it. Someone.
Okay, no, but it's not okay. No, but, because I just realized that, but it's
just click on the layers for the layer administration. No. Above in your toolbar, let's say, where you have my graphs, your legends, layers, where you save also. Okay, click on that one. And I think you just have to refresh it in the link above. In the title bar, you have a refresh. Okay, close it. And now, if you open a new map, it should not open automatically.
Okay. Because I didn't know. Yeah. Okay. So in that case, for the SST, for the Modis CSST front is the same. It's another product. Again, for this specific product, you see, it's most of the time very difficult to know where you are. So basically, before, I mean, to help us add the border without trying to understand where you are, and then it's much easier to recognize the region of interest. And then you can zoom in. Mayotte is there, close to the Comores. Okay, and this is the map I presented there. You have in the marine layer, you have the exclusive economic zone, which is a very important border for the fishery, already included. That can be also the region defined for our calculation. And finally, you can plot also the chlorophyll. So basically, it's the same thing. So it's the last product you can create. So basically, you have to go back to the map. You go to a new map, and that time you add the 3 days PML for chlorophyll. Modis did that one, and there is only one product. And then you generate the map. And you can play with it, you can change the title, you can do what you want. You can add the exclusive zone by adding the marine layer exclusive zone, exclusive economic area, or the major fishing areas that are also available. You can see the SST boxes on Tunisia layer this is a specific layer for Tunisia. And then you can also see the uncertainties and the problem of the cloud mask right now. If you prefer to use the Sentinel-3 with the daily product, you see we are much more accurate, but there are some differences in between the two products. If you compare the Modis and the Sentinel-3 product, you see that even the SST are a bit different. You have also some differences related to the cloud mask, and yeah, so you have So SST, the Sentinel-3 is maybe we should also think about creating a product with several days instead of only one, but it's maybe under reflection. And then derived from these SST maps, you have the fronts. So for the same period, you see what we got in terms of fronts for S3 and MODIS. So it's important because, and you see that we have some similarities. Be careful that, as again, PML is using several days. So it's more stable fronts instead of Sentinel-3, which is a very only one passage, one pass of the satellite that generate the map and then the front. So it's a very instantaneous data, whereas the PML is more something stable in time. But even that, you have some similarities between the two front detections. And yeah, so you can clearly compare those two data sets of fronts. It's in the middle, the two figures in the middle. So you have, for example, this kind of front there. It's important to compare the fronts. It's not because, I mean, you may have a big bias in between SST, but a very, very good or very close front detection, because front is just a separation, a variation of the value of SST. So if you have only MODIS is 2 degrees more than S3, you may have a big difference when you plot the SST, but maybe the front are very close. It's partially true. I mean, but you can see that we have some region here. We have some active regions, so it's not exactly the same. But you can see here in the north and very northmost place of Madagascar, or close to south of Mayotte, you have some active zone. Here you have nothing, not because you don't detect anything, it's because you have the cloud mask. That's why there is nothing. Whereas in the MODIS, you have some, using MODIS, you have data sets. So basically what we can do now, if you are in the institution and you have to provide a data set for the fishermen or about the fishery zone, so you can detect, you can draw a polygon, or you can select a big zone like that, or you can draw your own zone around an island. For example, if you're interested to the region south of close to Mayotte or whatever, so I deactivate the thing. So once I created the map, when I create the polygon, I can select it, and I can say, okay, now we're gonna see what is the evolution of the fishery conditions over that specific zone, and is there a specific period of the year or a specific period of the year or the season that fishermen should go there instead of another place. So you can even create two polygons, one on the eastern, and the other one on the western side of the island, and you can monitor your two zones, and then you can say at the end to the fishermen if they have to go eastward or westward when they have to go for fishing. So basically what I did is I selected a zone, I created this kind of zone. You can play with it if you have a map. You can create a zone, a polygon with the drawing box somewhere in the map. And once you have created the polygon, you click again on the polygon to stop to draw, and you can select it. Once it's your polygon is red, is selected, and then you can create a new graph. You start to know now how it works, and you select different product in the oceanography sector. Basically, what I selected here is the SST front, and the chlorophyll. See, so basically you can do the same. So you can select. So you can use the MODIS or the Sentinel-3. Up to you. And then you can show a specific period of time. So basically, because the data are quite complicated, are quite heavy, I recommend to reduce the number of it's better to reduce the size of your of the box and of the time series. So basically here there is a problem of duplication again. Oh no, sorry, it's because of University of Ghana. Oops, sorry, I made a mistake. Just to remind you that we have two boxes. So we have University of Ghana and IUC. In our case, we have to select IUC, 1 kilometer resolution. You see, when you select the chlorophyll, the subtitle is UOG or IUC. UOG means the University of Ghana is the box for Western Africa. IUC is the box for Mauritius. So the same for SST. I forgot if I think I made a mistake previously. So okay, so I can check the three products are all related to the good region IUC. Otherwise, I won't have any data because, of course, the data set for Mauritius, for West Africa is we don't have any data for this specific box. Then I can select a specific time. So instead of selecting instead of selecting 2020, I can select a very small period of time. So basically, if I want to fish, or if I want to analyze the fishery zone between the 11th of October, the week of the 11th of October, so basically from 11th to the 17th, and then I can draw. So basically, that will be the fishery conditions in that box defined here for the week of the 11th of October. And if you plot two maps, as I said, if you have two areas, you can compare. So you have to improve. I mean, you know how it works now to change it. But basically, if you play with all the options here, you can improve your graphic. You may have this kind of graphic for two different zones, and you can make an analysis for the fishermen's. So I think yeah, and okay, so that figure is not correct. I can improve if you play also. I don't know if you play with it as well, but okay. So the chlorophyll is in general it's a line. It's better to have a line. We're gonna put in black. Okay, why not? The 3 days SST will be in line as well, not too big and in red. Okay, and the SST front will be a bar. Black. We shouldn't use black because if we have already a color in black, we're going to use the green. And iodate. Okay, and this is okay. To avoid this kind of situation where the graph is behind the other, you have to start to draw the bars. So when you look at the product, you see that the SST front is plotted at the end. So that's why it is in front of in the graphic, and it's we don't see, it's not a good solution. You should avoid. So maybe better to shift the chlorophyll could be in bar and okay, and the front will be line. In that case, we avoid and we update. Okay. So it's not very comparable because I don't use the same thing, but for example, in that region, you see directly that if we consider that the SST front is a good solution, it's a good situation for the fishery, it was much better at the beginning of the week, then disappeared. but we have an increase of the chlorophyll detected, and we have a decrease of SST, maybe related to the increase of so maybe an upwelling or a local upwelling, for example. That can be the situation. I don't know exactly. And you can compare with another region. The OP fish for the moment is working for a daily time scale. Maybe we have some discussions if we have a lot of people interested to work on it and to improve it, to have the more 2 weeks, for example, 2 weeks product that is much more relevant for the, I mean, scientifically more relevant, because as shown by Jean-Noël Druon, a stable gradient of chlorophyll is much more propitious for fishery. Okay, I think it's over. Is there any question for this specific exercise? If no, I think it's done. I mean, I think it's I'm fine. If I look at I think it's we're on time.
We should have a break in 1 minute.
Yeah, it's time for a break. 15 minutes of break, and then we come back for the if you have any questions and for the conclusion remarks. I don't know if Marco is back.
Yes, I'm there. Hi, Christophe.
Okay, good. So so break for 15 minutes, and we come back for the last questions and conclusion remarks.
Hi, everyone. It's Marco. I don't know if you are all back. Meshak, are you there?
Hi, Marco. Yes, I'm around.
Okay, very good. Thanks for sharing the survey. And well, sorry for insisting on that, but we consider it very relevant for collecting your suggestions, mainly for improvements. If you agree, Meshak, we can resume the session and go to the final part, which is more on a question and answers and open discussion.
Exactly. Yeah, myself, I'm okay because it's already 6 p.m. here. So,
Yeah,
I think
and it's also Friday. Yeah.
and it's Friday.
So I understand it's a bit late.
Yeah.
Well, so without other hesitation, I would like just to ask the participants what they think. They want to see something more. They have specific requests about the product or the tools, the functionalities in the system. No any remark?
Okay. I don't know if they are back yet.
Hi, Marco. Aziz
Yep.
here.
Hi, Aziz.
Now, thank you very much for all the things you have done. No remark anymore, but just one point I wanted to raise before the end of this training. It's about the map set you should create for the Centre Suivi Ecologique when we left ISPRA in February 2019.
Yes.
I don't know if you work it on, but if yes, I would like to know what was done, and if not, what we have to do.
Yeah, indeed. So let me just double check the documentation. Because we have implemented indeed something for that. Maybe I can share my screen so that you will also see it online. Okay, do you see my screen?
Yes. Okay.
Okay, so with respect to the implementation we had that time, now we distinguished a bit, and you can see it also in the interface of the map set, the boundary box with respect to the pixel size and projection. So the resolution and the projection. Maybe I can also go back to the here it is. So it's taking a bit longer. So okay, so once you unlock it, you can go to the products, the map set. And for instance, if we go to I can go to any of them, but I would like just to, okay, spot the one for West Africa. Well, this is 30-meter resolution for the water bodies. But basically, you see that now you have a code of a map set and also the name. and it combines the projection, which is a lat-long simply, the resolution with this pixel size, and then with the also overall number of pixels, which being a high resolution now is very, very high. And then here is the bounding box. So that one is the one we defined for West Africa. And if you go to another map set for another product, for instance, 1 kilometer vegetation or 300 meter vegetation, you will see indeed different pixel size and size of the image, but exactly the same bounding box. So this is in the system, but is also as a working document. We have been working there. So yeah, I think these are the coordinates for Western Africa. Would you like me to send this information to you for double check offline at the end of this discussion?
No need, but I just wanted to understand what was the process, what you propose now, and something like this.
Yeah. Yeah. We took into account all the indication we received from you in this training or in this workshop, and we coded them into the system in order to group actually according to the region. So we have now the 5 regions: North, West, Central, South, and Eastern Africa for IGAD on land, let me say. And then we have similarly regions for the ocean, so Indian Ocean and University of Ghana, but there is also the NARS and CSIR. So I think we took into account that I remember that we spent some time on that, trying to. We had also some exchanges with the EU, the thematic expert, in order to see how we could better combine the regions. Then what you see when you go to the online probably is that you see the full extension. So there we store the data also for vegetation at 1 kilometer at the continental level, because as JSC we don't clip them to a specific region. For instance, if you go to LAI, you see that you have only Africa. On your system in CSC, if you install it and you set the thema as a CSC, you will see the Western Africa. So say we have more space here on our server in order to store data. We have several terabytes of space. And so there's no problem. We keep the data at the largest, on the largest windows available. While in the Mesa station itself, in your installation, they are clipped according to these different regions I just discussed. So indeed, there is a difference when you go to the online or when you look at your installation in this respect.
Okay, it's clear. Thanks.
Does it answer? Yeah.
Okay.
Thanks. Any other comment? I mean, how do you see the system feeding into your services? You are making use of him already? You have some specific requests for additional data sets? I see here another question from Youssef of the Africa Northern Zone. Okay, so let me double check. So indeed, speaking about land, yeah, you're not looking at the Mediterranean region. You're speaking about land product, Youssef, I think. So because you know that indeed they are differently defined. And when you look at North Africa, the Y, lower height should be, no. That's a bit weird. So let me see how the coordinates are defined. Let me see in the interface because there is something weird here. Okay. Yeah. So that is very general. I think it's very large in order to include. So the lower right latitude is 12. So it should go from 12 to 38. From 12 to 38. So let me go back. Okay, it is. I understand this is fine with you. Very good. Yeah. I am indeed. The system is operational, and every week, if not every day, we push data on the online version. We have already a number of users using it systematically, and also that they indicate if by any chance, by mistake, some data sets are not up to date for problems we might have on the services. So that is meant for operational usage and is there since couple of years already, really with the goal to be there and stay there. So indeed, your login is going to be valid from now on without any expiring date. You can go there and whatever you want to do, you can use it. And we know that there are people using it on behalf of the station really in order to do their analysis there. So basically, as you have seen, there are the workspaces that are associated to your account, to each user indeed, and you can really define them as you like. Now I'm not logged in, so I see only the reference workspaces. But if I log in here, I will see also my own workspaces. And the goal is that you really go there and you maybe starting from the reference workspaces, you see I have a number of workspaces for my test. Maybe starting from the reference ones, you will modify as Julian has demonstrated in the morning. You can save them by doing a duplication. This one is the default one. You can name as you like. Then, okay, let's name like that one. Once you save it, it does not rename that one. What you have to do is that you have to go into the list of your workspace, open it, and then you start really playing with it. So now is no, it's not that one. Sorry, I took the wrong one, but the idea is exactly the same. Once it is there, you can also rename it, then modify it. And once you're happy, you just save it again. So you can have a number of workspaces, and every time you go back, you will see exactly the same settings, the same scenario. If you select one thing, I don't know if you mentioned it, when you define the time of it, when you open a map, for instance, you create a new map, automatically goes to the most recent date, so to the latest data available for the data set. Indeed, I have to select a product in order to see something. And so if you don't modify it, and you just maybe now save your workspace with this additional map. Now, every time you open it, it will go to the most recent date, which is not going to be this second decade of November anymore. It's going to be maybe December, January in 2021, and so on. So that could also be good for creating a kind of dashboard. So you look at some data sets, and every time you log in, they will be updated. So these maps and these also the graphs, they are really dynamic objects that are just restored in the user interface every time you log in, based on some definitions in the database. So they are really objects that can also be updated, and in some cases like that one are automatically updated every time you log in. Then if you go to a date in the past, like this second date of May, now you save, again, the workspace, this date is going to be frozen. I mean, every time you open now, it's not going to be the date of 6 months before, but it's going to be exactly this specific date. So there are two usages of the system, and one of the two can be having really a dashboard to look at the current situation. In that case, you just select the latest data, and this is going to be updated. Yeah, so this is just a detail, but maybe can be of interest for you. So, Fahem, I hope this answers your question. You can log in. Okay, most welcome. Any other topic, remark from the participants?
Hi, Marco.
Yeah.
For the online version, is it all allowed for us to share with colleagues and something like this?
Yeah, clearly, it's exactly what I was about to say. That just communicate as much as you like and you can about this tool. We are most happy to see additional users. We have seen that today was still working decently with many people. I mean, 10 people maybe logged in, and so we are more than happy to have additional users. Consider also in the future, in a close future, we are going to migrate from what is now a virtual machine to a dedicated server. So that is going to be more powerful. So also the type of limitation we are experiencing those days are going to be less strong. So yeah, please do so, and we are going to be more than happy.
Okay, thanks.
Good. I don't know if there is any other question. Maybe we can go to the together now a bit to the survey. I understand it's late, but can also take only 4 minutes, maybe, for you to follow this link, so that I'm gonna show you a bit what is, and I invite you to do also now online. So you see that is just the email address, and my browser is proposing my default one. You can indicate the one you use for the DLP. I think is the best option. Now the first question is on the general satisfaction from your side on the today's section specifically of the training. So you can indicate from 1 to 5, and maybe something specific, positive and negative, according to what you feel, what you consider. Now, the following question is on the level of understanding of what we have seen today. So, how the station can be used in different thematic areas like agriculture, vegetation monitoring, also trends of biophysical variables. We have seen some examples with Christophe. And so here is about the understanding on the application of the system. And today we invited, we asked actually UC to insert this question, which is actually interesting for us, in order to know how you found the system reacting, if it was very quick or it was slow. So basically, if you say that the system was reacting immediately, I think you had to click on that one, no lag. My click was immediately executed immediately. Then, I mean, this is good, very good, and this is bad. So basically, it's not 1 to 5, it's a bit more detailed, but you can see, apart from that, which is the best one on the top, it will say, okay, good, fair, not very good, well, was low. So you can rate a bit your satisfaction, also your experience on that. And here is a bit more specific in order to indicate what was the most critical area, so where you have experienced the highest delay. So what was difficult to the slow processing of your request. So if you have experienced some issues, if it was in the customization of the maps, I don't know if you went on the legend creation, maybe you can also just here type something like maps were not displaying or took too long to display. I don't know, it's really up to you. Here is any specific suggestion on the improvement of the access to the online version of the station, while the following question is a bit on the training itself. So where do you feel you need more investment from our side, also as a common effort with AUC, for your understanding and adoption somehow of a station? So what's there you would like to see more treated in following training? We are considering having indeed other training session in 2021. So you can say, no, I think this was fine with me, or you can say, take one of these options, these choices, or just say, how can I implement an application on e-station for monitoring wetlands? I mean, can also be something very specific with respect to your needs. And also here you can specify also in a completely free form what you want to see in a subsequent training session again. And then is something as a general observation of the training. So from yesterday, so there was some comments about time. Time management, I don't know if it was only for the fact we did not really expect the indicated time in the agenda, or maybe something was too quick, something was presented too slow. Really open to you. Okay, that was just a bit to guide you a bit into the feeling of this survey, which is indeed important for us, especially in order to improve what we can do in the future. Okay. Okay, Johan is answering. Vijay, you have been already following up, so maybe you would like to intervene on this.
Yeah, regarding the GODPP.
No, sorry, it was Jurian. Was Jurian intervening? So it was not Vijay. Yeah, sorry.
What did you say? Marco, I missed your question.
Yeah, sorry, but we can go through it. So Nagla is asking about the possibility to download the products directly without creating maps and graphs. So the products we have, they are stored as a GeoTIFF files. And as was presented, I think yesterday by Julian, we have a GeoTIFF for each of the dates and indeed for each of the data sets. You can take them, yeah. There is an FTP server, and we can provide the credential to you. We can insert also for everyone into the presentation, into the material of the training, on how to reach into this website. So once you are there, you will see a very similar directory structure with respect to the one of the station itself. So we will find a subdirectory for all the products that you see also in the product navigator here. Okay, many. So one subdirectory for each of these products, and then the version selection, the area of interest, the subproduct, because you have many subproduct, and it's a bit like what you have here, but into a file system rather than into the user interface. So yeah, clearly we can provide you with the credentials in order to access there and download the data. Once you are going to have the station, what we did in conceiving the system is that we wanted to make available the system also within your LAN, the local area network of your institution, so that basically the station works as a pre-processing system in order to download the data. Sometimes they are in format that are not very convenient, maybe in segments. I think at Sentinel-3 it comes in stripes or even in small segments. We combine them. So the station just pre-process them to generate a single GeoTIFF for your region. And then you can access it from other computer, other application. You are familiar with Quantum GIS, maybe with a Snap, very different GIS tools. And also some processing that some algorithm you implemented in any language, in R, in Python, and so on. So we can provide additional information, starting with this reference of our FTP site. And indeed in the documentation, once you are going to have, as I think you are going to receive any station, you will see in our documentation exactly where the files are, how they are organized, and so on. And the Windows version, I think, Julian, there is on our website on station Jesse. I can copy and paste into the chat. Should be also in the reference documentation of the training somewhere, but no, it is not.
Yeah, I think it is there, but I'm not sure if you can go to the eStation website and then to web clients. Or no, it's not on the web clients. Huh? Yeah, the Windows version. Yeah, this should be the latest version. Yeah, and otherwise it's maybe best to download it from our FTP server, for which we will.
Okay. Okay, so it is there. Nagla for you to download from there. Our FTP site is described in the presentation we delivered.
No, I don't think so.
Okay, so I just take a point in order, an action in order to upload
the participants, both the FTP server and also indicated where the Windows version is and where the data is.
Okay. Okay, good. So that we're going to make sure that this is done in the is present in the documentation. Very good. Any other remark from your side?
Hi again, Marco, Aziza.
Hi.
Yeah, maybe a question about other product, but inland, because I have seen here you presented some profile product, but only for ocean parts. And we know that, for example, for our services in GMS in Africa, the water quality monitoring, we ask it to have such a product like profile, the lake water quality, or simply the total suspended matter concentration. What about that kind of product for the future?
Yes. I remember that we recorded all the requests into the conclusions of the training, basically. Then we were able to implement only some of them. You were here in February or March? I don't remember exactly.
In February 2019.
But,
yes.
Yeah, okay. So I can share my screen again. Okay. Do you recognize yourself here in the picture? Yeah, so but indeed, definitely this is the
Yes,
final.
I'm here between again and Julian, the guy. Yeah, this one.
This is you.
Yes,
Next to our Juliana. Very good.
Yes.
Yeah, okay, now I did not remember your name, but I remember your face. So let's go to the conclusions, because in the list of actions we indicated also the data sets to be considered. And I think the best on this question is to to go back to it offline, because I don't think I can provide you with an answer. I remember that with BJ also we passed in review all of the requests. For some reason, what is not now in the system is because for some reason was not possible to have it. If you can indicate a very specific product you are already using and or you are familiar with, and you want to have in the system, will facilitate a lot.
One. Okay, so this is the proposal. Yeah, for oil CI, for example, chlorophyll A and PSM, there are products available with Sentinel-3 data. So this was our request. I don't know if you was able to do, or if there is some issues, what kind of to understand. You can expect to have them in the near future or not.
Okay, Vijay, I don't remember that. Can you add something here on that? Because
we implemented this total suspended matter, but of course, Sentinel-3, it is mostly on the ocean, not on the inland, but the data is there also on the lakes and river. But since the resolution is 1 kilometer, we don't really see much on it. But I guess maybe if we go for 300 meters, we definitely going to spot also over all the rivers and lakes. Yeah. So, but yeah, this is what I remember, and yeah.
Okay. This is our as is this our tracking system, we base it on UTrack, is where you register all activities, all tickets, and so on. So we did something indeed on that. Let's double check. Had you had a look in the online version if it is visible or something?
Yeah. Total suspended matter should be there, or definitely.
No, Cloville it is, but TSM is not. Ah, no, it's true. It's there. Sorry.
Yeah, of course, TS. But yeah, only this is our production server. Maybe we should check on the online version. But for the in the Mesa station, it is definitely there if they have the latest version.
Okay.
So, yeah, this is what. But in some cases, you see, in some of the places over the lakes and river, the data is there. But of course, it is not super complete. I guess the 1 month data could help them, because we really take only the high quality data from the Sentinel-3. Because of a lot of noise, we disregard the unwanted, the noisy data. So also this is another reason we don't really have a complete image or complete coverage over the lakes and river.
Yeah.
And definitely on the West Africa, it is going to be difficult because of the resolution. I remember this, but I didn't think of West Africa. I just remembered CSC. I didn't think of it is in West Africa, so sorry for that. But since I thought it is there for over the Lake Victoria and on that part, I saw some data, so I thought maybe it will be useful for them. But I didn't really think it is specifically for the CSC, and I just remember it is for the West Africa.
Okay. Maybe I can just quickly check if we expose it also in the online version. No, it is all internally. So one action we can really quickly take, as this is that we push just externally for you to look at it and provide the feedback. Indeed, there is an issue on the resolution, because 1 kilometer is very rough resolution for, apart from the big lakes. It might also be the case that we cannot see really anything in your region. Okay, we can push it for you to look at it. If you can indicate, maybe just also with a screenshot from Google Maps, whatever GIS tool, where exactly you are going to look at, so a very specific region of interest, that's going to help, because when looking also at other products, we can really double check the region you indicate. As Vijay said, we are not expert really on this topic in Africa, so maybe we look just at the big lakes in Eastern Africa, and we see that there is some decent coverage, and we're happy with it. So if you can just send us a screenshot of there you are interested in looking these data sets, is going to be good.
Yeah, okay, I will do. But for our consortium, we are only working on West Africa, so from Senegal to Niger, I would say, Niger, Guinea. Okay, no problem.
Yeah.
I will send you the
yeah, clearly for the region you are looking at, not for Eastern Africa, for really the areas you are interested in. So just let me go very quickly. So you mean, for instance, these lake within this part? This can be an example. Lake Volta.
No, for example, go to Senegal, and in the north you have the Lac de Guiers. It's one of our study site.
Okay, that one.
No, in Senegal.
Yeah, I think it's that one.
Yeah, this one, Lac de Guiers.
Yeah. Okay, very good. So we can take this region and this lake as a reference in order to see which product, either this Sentinel-3 directly or other products can be appropriate. Yeah.
I guess
we have also a coastal site here, and near to Gambia, just in the north of Gambia, the wetlands near to the coast.
Near to the coast?
Yeah, in the north of Gambia, yeah. In the north, the west, yeah.
Yeah, we are in the north, yeah.
Yeah.
Not,
Delta
not,
Gambia. Here, north of Gambia. Yeah, here. You see Delta Salum.
okay.
At the left, left up.
Yeah.
Yeah, there. Go a bit up. Yeah, all this area. Yeah, this area you have here.
Okay.
All this area. It's one of our sites in Senegal also.
Very good. Okay, in Senegal, Delta du Saloum National Park, and also the Lake du Gruyère in the at the two extreme of Senegal, north and south. Oh, good. So we keep them as a reference. Thanks a lot, Aziz. Any other question or remark? I understand it's very late for you. So I think, well, from my side, I just thank you so much for being with us during these 2 days and interacting, providing your feedback. And it's been a pleasure for all of us in having this training. I don't know if my colleagues have additional remarks. Otherwise, I will give back the floor to AUC.
No remarks from my side.
No, also from my side.
Okay. Marco, thank you so much for that conclusion. Well, I really thank you so much, Yurian, Christoph, and Vijay. And we also had, the previous day, we also had Simona and, others who helped us during this training. And we really want to pass our regards as AUC because you've been very instrumental, especially on the usage